few what we call trig identities. Identities that's going to come from the Pythagorean theorem. So you learned a squared plus b squared equals c squared. And that's kind of on the same line, but all of these that we're going to do deal with trig. Now you're going to have to learn like 2 or 3 main ones. If you memorize the main ones, there are ways to do some algebra type stuff to manipulate them. So we're going to look at a lot of different ones, but they all come from like 3 different things. And then I've got I made an edge elastic that's just like out of a drag and drop to help you practice memorizing them over and over. The first one we're going to start with, I think, is like the easiest one. If you forget this one, this is one that you could kind of come up with yourself. And we know the Pythagorean theorem is a squared plus b squared equals c squared. Okay. So if I'm just going to look at like part of the unit circle, and if I make a right triangle, it's a unit circle, which tells us the radius is 1. So that right there is 1 because it's a unit circle. This length of the triangle, so like basically we have this point right here. The length of the triangle is whatever x value this is. So like if this is 0.75 units right here, the x is 0.75. So this is x. It's the x value. What do when trig, we had sine, cosine, tangent. Which one was like our x? When you looked at the coordinate, what was your x? Cosine. So this is really cosine. Or I'm not gonna put x because that'll confuse us. Let's put cosine of theta. Okay. The height of the triangle is like the y value of that coordinate. Which one was the y value? Sine. So we can kind of develop this triangle just by remembering that cosine is our x value. It's the length of the bottom. Sine is the y. So if we apply Pythagorean theorem to this, it would be, the way these normally go is we do sine first, but it doesn't really matter. Sine of theta squared plus cosine theta squared equals 1 squared. Now the way we write sine of theta squared, normally we put the square. It's just a notation difference, just to keep you from accidentally doing sine of x squared. You gotta be careful. Plus cosine squared theta, and what is 1 squared? 1. So this trig identity, like, this is just one of those things like I had ingrained in my brain, like I didn't forget it. Sine squared plus cosine squared equals 1. That's just, you gotta remember, you gotta memorize. Sine squared plus cosine squared equals 1. Now, there might be times when we have to rewrite things. I'm going to rewrite this right here. Plus cosine squared equals 1. You might, when we are manipulating or rewriting some of these trig, you might want to get this one, the sine squared, by itself. So if I, for some reason, needed to get it's simple, like don't overthink it. So subtract the cosine. Yep. So we're going to subtract so that's going to give us sine equals 1 minus cosine squared. You could do, you could do the same. You could switch out sign. So I'm just going to rewrite it under here. That would be cosine squared is 1 minus sine squared. So the problem could be written out so differently. If you just want you to rewrite stuff, and we'll do some examples so you'll see kind of the wording. Okay. Sine squared theta plus equals 1. Something else you could do if you needed to if you have an equation, it is mathematically acceptable to divide everything in that equation by something. So one of the identities you will see is we might divide each of the you could technically divide anything, divide them all. Specifically, you will see it dividing it all by sine squared. Divided by sine squared theta. 1. Okay. Cosine we just talked about it. It's cotangent. Over sine squared. What was 1 from the last lesson? Do you remember? It's cosecant. So this was cosecant. Asking you to rewrite, and you see squared or you see cosecant squared, it's probably going to come back to this identity. Which, if you forget what it is, if you don't have this whole thing memorized, if you at least memorize the first one, you might could come up with this one. Okay, this is not like this lesson is going to make or break your test. You're getting so it might be worth your while to memorize these. Okay. We can do this same thing, but dividing by cosine. So sine theta plus cosine squared theta equals 1. So I went back to that original Pythagorean identity, and I'm going to divide everything by cosine squared. Sine over cosine is tangent. So this would be tangent squared theta. Secant squared theta. Truly going to memorize these, like the big one. Like if you only memorize one of anything we do today before the AP exam, I would also recommend you just memorize. Okay. So those are called your Pythagorean identities. identities. So these are, yes, just memorization on these. Like I came from it out, maybe. I don't really know where these come from. If you have sine of two things added together, sine of any two things added together, that is the same as, let's see, all right, it's kind of long. Cosine B so if your original problem was plus, this one's going to be minus, this one's going to be minus. And then we have sine A. So it's sine cosine on both of them, but the first time it's AB, then it's BA. Okay. And that sign stays the same. And we'll look at some actual examples that go back. Now cosine, the first two, they're both cosine. So it's so you have cosine of two things added together. Now here's another difference. This symbol is going to be flip-flopped. The original problem had like A had something minus. You rewrite it, it would be a plus. The sign. Notice how those signs flipped. Okay, and then it's sine B. A plus B, cosine cosine, sine sine. And then I would memorize those two. And then the last. So the last two have sine of 2A. These are called Would you agree if I said, is 2A same thing? Yeah. Is 2A the same thing as A plus A? That's x times x. 2x. A is the same thing as 2A. So this would be sine plus this same concept A in both. So if you would be sine A cosine A plus cosine A. It's the same thing as 2 sine A cosine of 2a is cosine. Say, okay, 2a is the same thing as a plus. Up here, but use all a's. So that would be cosine a, cosine a. Now this one will be minus sine a. And if you multiply by something, so that's a minus sine a. I know that's a lot. I get that. On the back here, I've kind of put it all in a reference. Up top, cosecant is 1 over sine. Or sine is 1 over cosecant, same thing. If you're going to like truly memorize anything, for sure, you need to have this memorized right here. Of the ones we just did today. That one. I would recommend like these. You can kind of remember the cos go together. Cotangent squared plus 1 is cosecant squared. I highlighted all of like the final things. That one. Those two. Those two and those two. I mean, like in elementary school when you were memorizing spelling words, you wrote them over and over and over again. Like, honestly, you should do that. I would for sure memorize so if you're like, my brain can only memorize 3 things, I would the 3 pink, but I would prefer the highlighted ones. So now, what are we even going to use this? Because it's not going to just give you the formula for you to fill it in. So here's the type of question that you're going to see. Number 1, the function f is given by f of x equals tangent x over cosecant x. Rewrite f of x as a fraction involving powers of cosine and no other trig functions. So we've got to figure out how can I rewrite tangent cosecant as cosine only. Like you might have multiple cosines, but you shouldn't have anything other than cosine. So when you have a question like this, you might start working with something and then realize halfway through, no, this isn't going to get me there. That's okay. It's okay to like totally scrap what you were doing, cross it out, start over. I did that. Several of these that I was doing for practicing, I did that. Like you're not expected to get it right first time no matter what. So you got to be good with your algebra. Okay, you need to know that this is the same thing as this. I did not at the start of this year, this class, how much you would need to know, like just fractions, adding, subtracting fractions. Like we do a lot with that. Okay, so you can split up a fraction as the numerator times 1 over the denominator. Now, what do we know about tangent? It's what? Sine. It's sine over cosine. So we can rewrite this as sine x over cosine x. Okay. So cosecant matches with which trig function? It's the reciprocal of over as sine. So it's like sine over 1. This is times. You cannot. If the sign was in, you can cancel out a numerator denominator thing. But the signs don't. Which is sine squared or cosine x. I mean, these are truly, it's literally like a puzzle. Do I have, is my fraction now sine? No, I have a sine squared in there. The cosine. Okay. I've got to turn this back at our trig. We're going to use this sine squared x equals 1. So when we subtracted the cosine from both sides, it got sine squared squared x plus cosine equals 1. If I subtract the cosine, that's going to be 1 minus cosine, which means I can replace sine squared with 1 minus cosine squared. And now that gives me cosine and nothing else. So this right here is my final answer. Like if we had a lot of time, like I would normally probably spend, like if this was not an AP, like rigorous class, we'd spend a week or more doing these types of problems. We don't have that. If you just put these out of your brain, you're probably going to lose half the points on one FRQ. So you're probably going to lose 3 points there. Maybe 2 or 3 multiple choice. So you might be losing 6 points. Remember, our goal is for you to get like half of the points. So if this is the one thing, like, now, I'm not showing you anything on polar, which comes after this. It's its own thing. So we're going to take the hit on those. But still, without having this, that's enough, like, that you could easily pass the AP exam. But I still want to show you these, because if you're, can memorize, you can. Now, every time I've seen an example like number 2 where there are fractions in there, it's for difference identities, almost always. Or the double angle, it's one of those. So, which of the following is equivalent to look back at your identities, your reference. Tell me where you see something that has a 2 and then a sign and infinity. Does it look like a 2, a sine something, cosine something? It's the sine of 2x, sine x, cosine x. That is the identity. This pi over 14 by x. So x would be pi over 14. And that's equal to 2x. So sine times pi over 14. The 14 simplify to. Pi over 7. Let's see. You are like, there's no way you could get this without know this identity to be able to do questions like this. All right, the next one, K over cosine of 2x. With cosine of 2x. That 4, I'm just 2x, pretty simple, is bottom right, cos something that looked just like that in my answer choices. 4 cosine squared x minus 4 no. So at this point you're either thinking I did something totally wrong or I could keep working on it. Memorize and you knew that was correct, then you're going to need working on it. And there's a couple of things that you could do. sine squared x. We can replace sine squared x with this. Think of that and see if that gets me an answer. Minus 4. This would be 1 minus plus 4 cosine. And these are like terms, making 8 cosine squared x. Is that an answer choice? No. Okay. 4. You're probably, if you see fraction, it's going to be either the sum difference or the double angle one. It's going to be the sum or difference one. So look back at your identities and see which one you have cosine, cosine, and then sine, sine. It's the one that starts with sine or the one that starts with cosine? It's the one that starts with cosine. So I'm just going to rewrite that here. Cosine A plus minus B equals cosine B sine A sine B. Right under it. I know I can narrow this one down. I know this has got to be cosine of something. So if you kind of have these, one goes with cosine, and that's all you know, you can narrow down and get a 50-50 shot. Okay. If A plus B. If this one is subtracting. So your cosine, your signs are opposite. And B is pi over 16. That's just kind of that's just part of the formula. To be able to add fractions, you need a common denominator. So plus, which is going to be 3 pi over 16. . which is going to give us C. And really from these, I can bet that you're going to have one choice where it's adding the fractions and one choice which is subtracting. So if you know you're going to be adding, then just go with the bigger one, even if you forget how to add fractions. Okay. But some, you know, if you kind of remember a little bit, you can narrow it down. Next one. So here we have a figure. It's explaining everything that's explained here is in the picture, but notice the numbers don't match up with a true unit circle. This is the point 512, so this length has to be 5. This height has to be 12. Does anybody know the Pythagorean triple, what this third side is going to be? 13. 5, 12, 13 is a Pythagorean triple. Okay. Or you could do Pythagorean theorem to figure it out. And this is, this question does require SOHCAHTOA, which we, SOHCAHTOA. And you're not going to need tangent. So I'm going to write sine of theta. It's opposite over hypotenuse. So 12 over 13. Cosine theta is adjacent over hypotenuse. So 5 over 13. Now the question is saying what is sine of 2 theta? That's a Pythagorean theorem, or a Pythagorean, or a trig identity, sorry. Sine of 2x is equal to sine x cosine, or no, sorry, 2 sine x cosine x. And I know that sine x or sine theta is the fraction 12 over 13. I know cosine is the fraction 5 over 13. So we're literally just going to do some computations. So this would be 60 over 169 times 2 is 120 over 169. Two more. There's so, like, the problem with this is there's like so many variances of questions you could be asked. So I'll just try to give lots of different examples. I know it's lengthy and boring, but it is what it is. Alright, I'll have this one right now. So, we know that our goal is to get tangent. So if I'm approaching this and I have no idea where to go, I'm going to start by kind of splitting up my fraction. Sine x cosine squared x times 1 over cosecant x. Maybe this gets me what I need, maybe it doesn't. We'll see. That's why you're going to have a pencil on the AP exam. What do we know? What is 1 over cosecant? Or what is cosecant reciprocal of? Sine. So that's the same thing as sine x times cosine squared x times sine x. And we're multiplying. If you're multiplying, you can rearrange things, and sine times sine is sine squared. So this is sine squared x, cosine squared x. Okay. Let's see. So I've not worked this one out either. Alright, so sine squared times, it's not the same thing as the sine squared plus cosine squared. So I'm probably, if I'm attempting, I'm probably gonna do some one with 1 minus sine squared. That would just give me sine to the 4th. Just gonna make me think it. I don't, like, I looked up, like, trig solvers, calculators. I don't think we can do this one. I think that's either an identity that I don't know, or I just miswrote it. Alright, next one, involving secant. Cosecant, let's see if we can do this one. Cosecant tangent x. Cosecant is 1 over sine. Tangent is sine over cosine. Oh yeah, this one's easy. You have a sine bottom, you can cancel them, leaving us with 1 over cosine, which is just